Hello physics class, welcome to my third week back. We're working at forces, at angles, including friction. So last week we looked at friction, how does it actually interact with the forces. It's always a slowing down of the motion based off of a ratio or percentage. So when things slide and interact, again, that's when our friction actually gets involved. And I thought last week went pretty well, so most of you done pretty darn well with that topic. I'm hoping to see most of you actually in class, in lab this week to kind of play with some of these. And we'll be actually in the bio lab instead of the chem lab, but we'll be in playing with some of these objects, and we'll also be playing with, actually where are they? There it is. Playing with some of these. These are little force scales, so it shows you how much force is actually being pulled when you pull some of these things. All right, so we're going to be pulling at angles. What does that change? So if I'm just pulling straight across, or if I'm pulling at an angle, what's the difference when I'm actually, like, what does that change? How does that make a difference when we're actually trying to figure out acceleration, net force, and that kind of stuff? It's going to change a couple things, because first off, we're going to have to break it off into sections. So if I pull at an angle like this hopefully looks very similar to what we did at the start of the year when we talked about vectors, breaking vectors into two parts, into an x component and a y component. And that's going to be important because when I pull at an angle, technically the force that I'm pulling upwards isn't going to actually move it this way. It's only the x component. And the one thing that's going to change this week is how force normal interacts with the actual coefficient of friction. So to find friction force, if you look at last week's videos or kind of remember, to find friction force, you have to go mu, the coefficient of friction, times force normal. And force normal has always just been basically the same as force of gravity, which is just the mass times 9.8. And that's just what your force of gravity is, and that's the same for force normal. It's always been the same. Force normal is going to kind of change a little bit because of what we're doing now. Again, let's go through a little tiny overview of what force normal is. Force normal is how much this table has to apply a force to keep this thing up. Again, if I stand on a piece of paper, that piece of paper is not going to hold me up. That paper doesn't have enough force. But if I sit on this table, hopefully this table doesn't break, this table is going to support me. So obviously it has the same force pushing back on me. I'm not moving. Okay? So that's what force normal is. It's how much the table has to push to keep that object upright and not going through it. So now, when I'm pulling up, and I have this, like this y direction force, I'm pulling up and across, how does it change? Well, it changes because what if I pull so hard up that it's like this now? Well, is there any friction? I don't think so. I think there's no friction because it's not touching anymore. And so each time I slowly pull up, there's going to be less and less like work or force for the table to hold it up because I'm taking some of that force away. So when I pull up, some of that force normal is not going to be there. So when we find this force of y, we're going to be interacting with that of the force normal to actually find our friction force. So that's just a little intro into kind of this week and to kind of get you ready for the lab that we're about to do. I will be doing still a bunch more YouTube videos about showing the free body diagrams and the math work that goes with it and some questions obviously. But I'm excited to see you guys in the lab. If you can't make it on for your scheduled time, please message me. Please try and find a way that hopefully we can get into this lab and interact a little bit because it's a lot more fun to play with this and understand it when you actually get to kind of interact with it. So hope to see you all this week. Have a great day.